Hello, everybody. This is Coach Shafto. Today, we're looking at our Carnegie book, page M3.94 through M3.97. And what we're trying to do is we're trying to say that I can use properties to write equivalent equations. And so we talked about last video how sometimes an equation is similar to a seesaw, where you have the equal sign in the middle, and then the two sides need to be the same weight as each other to keep everything balanced. And so there's some rules that we can use to make sure that our equation stays balanced. Later on, we'll use those same rules to be able to solve equations when we don't know what a variable is. We are on page M3.94 on activity 1.3, using properties of equality. So let's go through and try and understand what this is trying to tell us. To begin, it says the addition property of equality states that if two values A and B are equal, when you add the same value C to each of the sums, then those also are equal. So basically, this is what that's telling us. It's telling us that if I've got A and B and that they're equal, if I add C to both sides like I have here and here, since A and B are equal, if I add C to both sides, it means that both sides are still equal. And then the subtraction property says that if I subtract C from both sides, then they're always equal. Imagine that you had a seesaw. And what this is saying is if it's balanced beforehand, and then I add another person to both sides, as long as those people are the same weight, it's still balanced. Or if I take away something from both sides, as long as what I take away is the same, C and C, then it's still balanced. Question 1 says, suppose you have the equation x equals 15. It says use the addition property of equality to write at least 3 equations that have the same solution. And so what we can do is we can say, well, my base is x equals 15, which is right here, x equals 15. And so then I can say 3 equations. So I'm going to divide this up. Let's do equation 1. And we'll say that equation 1 is, we'll say, x plus 2 will be equal to 15 plus 2. And these are the same. And this would be the same as writing x plus 2 is equal to 17. My second equation, I could write something like x plus 10 is equal to 15 plus 10. And this would be the same thing as writing x plus 10 is equal to 25. My last equation that I want to write, I could write something like x plus 4 is equal to 15 plus 4. And this would be the same as writing x plus 4 is equal to 19. Again, I wrote 3 equations, and they're equal. And all I did was I took my original, and then I changed up the same on both sides. This says to use this, B says to use the subtraction property to write at least 3 equations. So let's do the same thing that we just did. I could write something like x minus 2 equals 15 minus 2, which would be the same as writing x minus 2 equals 13. For my second one, I could write x minus 4 equals 15 minus 4. And this would be the same as writing x minus 4 equals 11. For my last one, I could say x minus 10 is equal to 15. minus 10. And this would be the same as writing x minus 10 is equal to 5. In problem 2, it says, suppose you have the equation x plus 5 equals 1 plus 9. So it's a little bit more complicated here, but the basic idea is the same. So it says use the addition property to write at least 3 equations that have the same solution. So let's do the same thing we've been doing. My first equation I'm going to write would be, let's say, x plus 5, and then I'll write plus 2 is going to be equal to 1 plus 9, and then plus 2. And so this is going to be the same as x plus 7, which is equal to 1 plus 9 is 10, and 10 plus 2 is 12. Again, all I've done is I've changed the plus 2 and the plus 2. The rest of it is still the same as my original problem here. My next equation I'm going to write could be something like x plus 5, and then something, equals 1 plus 9, and then something. So I'm going to use some color coding here to show the difference. So I could say plus 3. And if I did it there, I need to do plus 3 on the other side. So if I were to take this, this would be x plus 8 is equal to 10 plus 3 is 13. My last equation, I'm going to write x plus 5 plus something is equal to 1 plus 9 plus something. And so if I said, let's say plus 4, I have to do the same on both sides, which means I now end up with x plus 9, which is equal to 14. My last problem says to use the subtraction property to write at least 3 equations. So the first one I'm going to do, I could say x plus 5 and something is equal to 1 plus 9 and then something. And so I'd like to do, let's say, minus 5. And this is going to give me x plus 0, so I'm just going to leave it as x, which this now is going to be equal to 5. And so you notice that we can actually use this rule, that whatever I do on one side, I do the same to the other, to figure out what is x supposed to be. My next equation, I'm going to write x plus 5 is equal to 1 plus 9. And so let's go ahead and say minus 6. And so this is going to give me x plus 5 minus 6 is going to be negative 1. So notice that you can have negatives in here, is equal to 1 plus 9 is 10, and 10 minus 6 is 4. My last set, I'm going to write x plus 5 is equal to 1 plus 9. So let's go ahead and do minus 2. And this is going to give me x plus 3, because 5 minus 2 is 3, is equal to 1 plus 9 is 10. 10 minus 2 is 8. And so now I'm done with that section. On the next page, it talks about the multiplication property of equality, which states that if two values a and b are equal, then if you multiply them by the same on both sides, then the products, which you multiplied, will be equal. So if A and B are the same, and if I just take these and multiply times C, like here and here, then whatever answer I get will also be the same. And the division property is similar. If I have A and B, and those are the same number, and then I take them and I multiply them times C, or divide them, I'm going to get the same thing. So for example, if I had 2, which is equal to 2, and then I take them and multiply times 3, then both of these answers will be equal to 6, and they're both the same. So question 3 says, suppose you have the equation x equals 5. Use the multiplication property of equality to write at least 3 equations that have the same solution. So I'm going to take x equals 5, and so I have x in parentheses, and then that's equal to 5. I'm going to put that in parentheses as well. And so say we did 3 times x equals 5 times 3. And so my solution here would be to say, well, 3x is equal to 15. I could do another problem, and I could put x equals 5. And then if I multiply, let's say, times 5 on both sides, this is going to give me 5 times x is 5x, which is equal to 25. Let's write one more problem. We'll say we use a fraction. If I have x equals 5, let's say I took half of x and half of 5. This is going to then give me 1/2 of an x will be equal to half of 5 is 2.5. B says to use the division property of equality to write at least 3 equations that have the same solution. So if I look at this, it says x equals 5. And so we want to divide on both sides, and we're going to use a fraction bar. So if I divide it by 2 on both sides, this is going to give me x over 2 equals 2.5. Notice that it's the same as our problem up here, because dividing by 2 is the same as multiplying times 1/2. If we look at the next problem, we could do, say, x and 1. So if I had x equals 5, and let's say we divide both of them by 1 using a fraction bar. This is going to take me over, and I'm going to have x divided by 1 is just an x, and 5 divided by 1 is just going to be 5. And this is actually called the identity property of division, which means that when I divide by 1, I get the same thing. Lastly, let's say x equals 5, and let's say we divide by 5 on both sides. This is then going to take me to have x over 5 is equal to 5 divided by 5 is 1. And so we have a new equation, which is still balanced. Question 4 says, suppose you have the equation 1/2 x equals 10. And this is going to be a little bit more challenging because we have fractions and we don't have much space. So if I have 1/2 equals 10, and let's put that in parentheses. it says to use the multiplication property of equality to solve this. So if I did times 2 on both sides, then I end up with 2 times 1/2 is just 1x, which is going to be equal to 10 times 2 is 20. So half of an x equals 10 is the same as writing x equals 20. Alternatively, if I had 1/2 x equals 10, we could take this and multiply it times 4. And this is going to give me, in our next section, I would have 4 times 1/2. Well, half of 4 is 2x, and then 4 times 10 is 40. So 2x's equals 40. Now I'm going to stop there. You can do the third one, but I don't have room. B says to use the division property of equality to write at least 3 equations that have the same solution. Again, I'm just going to do 2. So the first one, I could take half of an x, which is equal to 10. And let's pretend like we divide by 1/2. So if I take a half divided by a half, that's just going to give me 1, because anything divided by itself is 1. So I get 1x by itself. And if I take 10 cut into pieces that are 1/2 each, that means there's 2 pieces in each whole, which is really sort of like multiplying. And this makes sense because remember, if we divide, we would take 10 divided by 1/2. We'd keep, change reciprocal. So we take 10 times 2 over 1, which gives me 20. So my answer is x equals 20. Alternatively, I could say, what if I took half of x and I divided it by 5? I took 1/2 x equals 10. And I wanted to divide this by 5. This is going to give me 1/2 divided by 5 over 1. Keep, change reciprocal is 1/2 times 1 over 5, which is going to be 1/10. So they give 1/10 of x, which is equal to 2, because 10 divided by 5 is 2. So again, my equation ends up being still with a fraction, but it's still balanced. Next, question 5 says describe how you can check your solution to equations in question number 1 and question number 3. So question number 1 and 3 just gave us x equals 5 directly. And so since we have what quote unquote the answer is already, if you go back and look at your equation, say 5x equals 15, sorry, 3x equals 15 right here, and I wrote 3x equals 15. Well, I could write 3 parentheses. We know x is 5 equals 15. So this tells me that 3 times 5 is 15 equals 15. And so we know it's right because we use substitution. In the next section, you're going to have to match. We're going to need to take the equation cards, which are on page M3.103, page M3.103. And so that's going to be right here, and we'll walk through how to match these. So for question 1, it just says to match them that have solutions. So let's see what we can do here. I've got my equations, which are in white, and my solutions, or my answers, which are in green. So let's see if I can find an easy equation. I see one. This one I know is very easy. 45 is equal to 5 times something. And so I know that 5 times 9 makes 45. So I'm going to match these together. My next one, let's look at 11 plus x equals 11. And so this one is pretty easy as well. If I took 11 plus something equals 11, well, my answer there clearly has to be 0. So this matches with. Let's look at our next one. Let's look at 0 times x equals 0. So I could put 1 in there. 0 times 1 is 0. Or I could put 2 in there. 0 times 2 is 0. Or I could put 100 in there. 0 times 100 is 0. And I could really put anything I want because 0 times anything is always anything. So this one actually has infinite solutions. Let's look at the next one. Something divided by 9 is equal to 2. Well, we know that 18 divided by 9 is going to be equal to 2. So these ones match together. Let's find another easy one. X plus 0 equals x. So if I put 10 in there, 10 plus 0 would be 10. Or 5 plus 0 would be 5. Or 100 plus 0 would be 100. So it doesn't matter what I put in here. It's always going to be the same, and it's going to be true. So that has infinite solutions. Number 29 says 29 equals x times 29. I know that anytime I have something times 1, I get the exact same thing. And so those two are going to match together. This guy is very similar to the one with 0 because x plus 1 is equal to x. And so it has infinite solutions because it's just the same number plus, oh, wait, this is wrong. This actually has no solutions because say if we picked 2, 2 plus 1 is 3, not 2. And if we picked 4, 4 plus 1 is 5, not 4. So this has no solutions. It's always going to be wrong. Look at this one. 10x equals 30. I know that 10 times 3 is 30, so let's match that together. Let's look at this guy. X times 1 equals x. So there's actually going to be infinite solutions because anything times itself is the exact same thing. So 5 times 1 is 5, and 2 times 1 is 2. Let's look at this one. 5 is equal to x plus 5. Well, this clearly matches with 0. And so it's actually going to be here with the multiplication and the others. Some of these are getting a little bit harder. So let's look at this guy. I know that 1/2 is the same as 4/8. So 4/8 plus 1/8 will make 5/8. So 1/8, these two match together. The next one that I see is I have something divided by 3 plus 10 is 20. So if I take that, this would have to be 30, because 30 divided by 3 is 10, and then 10 plus 10 makes 20. This guy would be an eighth of what number makes 8? Well, I know that 8 times 8 makes 64. And so if I'm dividing, because 1/8 is the same as divided by 8, 64 divided by 8 is going to make 8. The next one, 10 over some number is equal to 1/10. Well, that's going to be 100, because 10 over 100 makes 1/10, because 10 goes into 100 10 times. This guy right here is actually infinite, because dividing by 4 is the same as 1/4. So these are actually the same problem, just one of them uses a fraction and one of them has an invisible 1. This is infinite because this is the same problem, 4 and 4, and it just adds x to it. So they're functionally the same, and so you can put whatever you want in there, and if you just add 4, you'll always get the same thing. Let's look at this. I think these ones go together, just because they look like they have decimals. So x plus 3.5 is 14.25. Yep, those are definitely together. One times a number plus 6 is 9. That should go with 3, so this matches here. Here I have x minus 5 is the same as x minus 4. Well, those are basically the same problem, except they're off by 1, so they're going to have no solution ever. Then finally, I have something over 10 is 0.1. So I know that 1 over 10 is 0.1. So 1 is one of my answers. So that's going to go down here with this guy. And I have 3 left over that don't actually match anywhere. Down here, don't worry about answering question 2. But essentially, down here, we can write for question 2. We know that, on question 1, we can substitute to see if these solutions work. On question 2, these equations will never work because they're basically the same, but they have different constants. As an example, well, you have the examples on the other side. These ones have infinite solutions because they are the same on both sides, or equivalent on both sides. If we look at that, we see these ones with infinite solutions, x times 1 is just x. Those are the same. They just look different. Over here, X plus 0 is just X. Those are the same. There's just a 0 there. 0 times X, everybody knows when you multiply by 0, you get 0, so they're the same. Over here, they're exactly the same. And right here, they're the same, they just look different. In the next section, it says, consider each property. The 0 property of multiplication states that the product of any number and 0 is 0. So which equation states the 0 property? This is the 0 property. Anything times 0 is 0. That's going to be right there. B, which equation states the identity property? Well, the identity property states that the product of any number and 1 is that same number. So the identity property, if we look over here, we have any number times 1 is the same number. That's the identity property. Which equation states the identity property of addition? This identity property of addition says that the sum of any number and 0 is the same number. So if I take any number plus 0, I get the same number. It's right there. 3 of the solution cards did not match. It says write equations that make those values solutions. And so if we go back and we get our solution cards, these are my solution cards that didn't match, and I need to write an equation that will match with these solutions. So let's figure it out. So we have a 1/4, a 0.1, and a 6. If I take 1/4, I could say 1/4 of 20 is equal to 5, because 1/4 is the same as dividing by 4. And so 20 divided by 4 is 5. So if I wrote 20x equals 5, that would be my equation. If I took x equals 6, I could write 6 times 4 plus 2 equals 26. And you can make up your own. But this would be 6 times 4 is 24. 24 plus 2 is 26. So this would be 4x plus 2 equals 26. And that would be my equation. Finally, if I had x equals 0.1, I'm going to do an easy one here. I could have 0.1 plus 3 equals 3.1. And this would just be writing x plus 3 equals 3.1. Remember to complete all the questions, and if you need other assignments, you can find them on Google Classroom.